So this one's a short one. Part 191, line 18c, point-like particle physics, Newton, Einstein Gravitational Force, 5G Wow Seti. There's the alien radio signal, and this is a quote from Wiki. This is all data, okay? A point particle, ideal particle, or point-like particle, often spelled point-like particle, is an idealization of particles heavily used in physics. Its defining feature is that it lacks spatial extension. Being zero-dimensional, it does not take up space. A point particle is an appropriate representation of any object whose size, shape, and structure is irrelevant in a given context. For example, from far enough away, an object of any shape will look and behave as a point-like object. In the theory of gravity, physics often discuss a point mass, meaning a point particle with a non-zero mass, and no other properties or structure. Likewise, in electromagnetism, physics discuss a point charge, a point particle with a non-zero charge. Sometimes, due to specific combinations of properties, extended objects behave as point-like even if they're in their immediate vicinity. For example, spherical objects interacting in three-dimensional space, whose interactions are described by the inverse square law, behave in such a way as if all their matter were concentrated in their geomagnetic centers. In Newtonian gravitation and classical electromagnetism, for example, the respective fields outside of a spherical object are identical to those of a point particle of equal charge mass located at the center of the sphere. So this is interesting because we're talking about making a sphere with something in the middle of it, right? In quantum mechanics, the concept of a point particle is complicated by the Heisenberg uncertainty principle. Even an elementary particle with no internal structure occupies a non-zero volume. For example, a 1s electron in a hydrogen atom occupies a volume of 10 minus 30 m3. There is nevertheless a distinction between elementary particles such as electrons or quarks, which have no internal structure, versus composite particles such as protons, which do have internal structure. A proton is made up of 3 quarks. Elementary particles are sometimes called point particles, but this is in a different sense than discussed above. For more details, see elementary particle. My thoughts: neutrinos are here. The gravitational constant G is a key quantity in Newton's law of universal gravitation. The gravitational constant, denoted by letter G, is an empirical physical constant involved in the calculation of gravitational forces between two bodies. It appears in Newton's law of universal gravitation and Albert Einstein's theory of general relativity. It is also known as the universal gravitational constant, Newton's constant, and colloquially as big G. It should not be confused with little g, which is the local gravitational field, equivalent to the free fall acceleration, especially that at the Earth's surface. So these are two different mathematical equations, which, according to this, it talks about the sphere, the center of the sphere, which is what we were making for the middle part of the UFO. So I'm assuming in this respect it's saying you're going to be using these math equations when you build that particular device.